Hello everyone. In this video we are going to discuss some examples based on the topics which we covered in the last video, that is mutually exclusive and exhaustive events. Let us go through this example. Two dice are thrown and the sum of numbers which come up on the dice is noted. Let us consider the following events. Event A is the sum is even. Event B is the sum is multiple of 3. Event C is the sum is less than 4 and event D is the sum is greater than 11. So question is, which pairs are mutually exclusive? So first, what is mutually exclusive events? So if E1 and E2 are two events, if their intersection is empty, we call these E1 and E2 as mutually exclusive events. So first, we will go through these events, what actually those are. A is the sum is even. So first of all, how many possibilities are there for a sum? So on both the dice, there are 6 possible outcomes. 1, 2, 3, 4, 5, 6. So sum can be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are only possible sums. So the sum is even number. Even number means 2, 4, 6, 8, 10 or 12. Only those possibilities are there. Again, you can observe 2 plus 2 is 4. So even plus even will give you even number. 2 plus 3 is 5. Even plus odd gives you odd number. But 3 plus 3 is 6. So odd plus odd will also give you even number. A is the sum is even. So what I will look? Both the possibilities which are even or both the possibilities which are odd. So my event A will look like both even I am looking for. So even with even, even with even, even with even. Now if I change the first digit, 4 with 2, 4 with 4, 4 with 6, also 6 with 2, 6 with 4, 6 with 6. Now these are all possible even pairs. Now odd pairs. Odd means 1, 3 or 5 only. So 1 with 1, 1, 3, 1, 5, 3, 1, 3, 3, 3, 5 and 5, 1, 5, 2, 5, 3. So these are all possible outcomes for this event A. Now event B, the sum is multiple of 3. So how many multiples of 3 are there? You can see 3, 6, 9 and 12. So sum should be 3, 6, 9 or 12. So let's see. If I want sum as 3, how many possibilities are there? If it comes up like 1, 2, the sum is 3. 2, 1 also sum is 3. Now, is there any other possibility for 3? No. So I will go through 6. For 6, I need 1 or 5. 5 or 1 is also possible. Then 3, 3 is also fine. 2, 4. 4, 2 is also fine. Is there any other possibility for 6? No. Now go for 9. So how can I get 9? With 1 I cannot combine anything to get 9. Because there are only 1, 2, 3, 4, 5 and 6. So 1 plus anything among these 6 numbers cannot give you 9. So 2 is also not possible. 3, is it possible? Yes. If I combine 3 with 6, that will give you 9. Similarly, 6, 3 is also 9. Now any other possibility? Yes, I can combine 4 with 5, 5 with 4. 6, 3 is also already there. So 9, is there any other possibility? No. Now I go for 12. So how many possibilities are for 12 there? 6 6. That's it. So B is this event. Now C, the sum is less than 4. Less than 4 means it can be 1, 2 or 3. So similarly, what we have observed in B, we can get sum as 1 only in one possible way, 0 1 or 1 0. But 0 is not our favorable outcome. So this is not possible. So I cannot get 1 anytime. 2, is it possible? Yes, only for this case, 1 1. Now for 3, these are the possibilities. So is there any other possibility for sum less than 4? No. So these are your possible outcomes for C. Now let's go for the event D. The sum is greater than 11. So sum can be only these numbers 2, 3, 4 up to 12. So greater than 11 means what? Only 12. So 12 I can get in only one way, if both the dice give you 6 6. So these are my A, B, C and D. The question was which pairs are mutually exclusive. So the definition which I gave you in the beginning only, it was if the intersection is empty, those two events are called as mutually exclusive. Now let's see. We will go by pair. So A and B, are there any common elements? Even if we get one common element, that intersection is non-empty. So that will do the work. So is there any common element? Let's see. And am I getting 2 2 here? No. 2 4 here? No. Yes, 2 4 is there. So one element will serve. So intersection of A and B is non-empty because I have found one element. There may be other also, but only one element is also telling me that A intersection B is not empty. So A and B are not mutually exclusive. Similarly, for B and C, check. For B and C, is this 1 1 there in B? No. Is this 1 2 there in B? Yes, 1 2 is there. So B and C also have some common elements. So the intersection is non-empty. Now let's go for B and D. This 6 6 is there. In B and D, this element is common. So B intersection D is also not empty. Now let's see C and D. Is any element common in these two? No. So C intersection D is empty. So we have seen that only this pair CD is mutually exclusive. Others, whichever pairs we have considered, all those pairs are not mutually exclusive. Now, one more definition we have seen in the last video. It was for exhaustive events. So, what are exhaustive events? If I collect all the possible outcomes for A, B, C, D, means if I take the union of all the events A, B, C and D, I should get the whole sample space. So, if I take the union of A with B, with C, with D, am I getting the sample space S? Sample space S means all 6 into 6, that is 36 outcomes. Am I getting all those 36 outcomes here? Let's look. So 1 2 I have. Do I have 1 3? Yes, I have 1 3, 1 1. Do I have 1 4? No. So there are some elements which are missing. Even if I take the union of all these 4 elements, I am not getting all the elements which are possible for the sample space of this experiment of throwing 2 dice simultaneously. I should get 36 outcomes, but there are not, means if you add up all these outcomes also, you will not get 36 outcomes. So that means A, B, C and D are not exhaustive events, and we have seen these pairs A, B, B, C, B, D, these are not mutually exclusive, but pair C and D is mutually exclusive. Let us go through another example. A coin is tossed 3 times. Consider the following 3 events. So if I first, what is the sample space for this event? If a coin is tossed 3 times, so all can be heads, 2 can be heads and 1 tail. So that tail can be anywhere, in between or on the first place also. If I have 1 head, 2 tails, so the order may be different. So T, H, T, 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 H and all 3 tails. So all these 8 possibilities are in sample space. Now let's see this first example, first event. No head appears. So no head appears means only this possibility, T, T, T. Exactly 1 head appears. Exactly 1 head means head, tail, 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 head, tail and tail, tail, head. At least 2 heads appears means there is 1 tail and 2 heads. At least 2 heads means 3 heads is also fine. So head, head, head. Now see, are these 3 events mutually exclusive or are these 3 events exhaustive? Let's see. For mutually exclusive, we look for common elements. So is there any common element in A and B? No. So A and B are mutually exclusive. Now B and C, is there any common element? Is there any common element? No. So B and C are also mutually exclusive. Now A and C, is there any common element? No. So A and C, all the 3 pairs are mutually exclusive. But now look at the union of all these 3. So can I get this whole sample space S? So look, triple H is there? Yeah, we have that triple H. Then HHT, we have HHT, HTH, it is there, THH, it is there, HTT, it is there, THT, it is there, TTH and TTT. So all the elements in sample space are covered in the union of 3 events A, B and C. So A union B union C is S, means A, B, C are exhaustive events. So I can say A, B, C are mutually exclusive also and exhaustive also. So we will go deeper into some other examples in the next video. Thank you.